Good afternoon, everyone. So today we're going to start talking a little more in detail about compound interest. So you should be getting a handout, so a template to go with this note that has the skeleton of the note there, but you have to fill in the examples as we go. So please make sure you've got something to write with, and we'll get going here. So yesterday, with the activity we did with Google Sheets, okay, hopefully you have a little bit of an idea of what's going on with compound interest works as compared to simple interest, right? So with simple interest, you just kind of keep earning the same amount of money over and over again, where with compound interest, the money grows faster because you deposit your interest and then calculate your new amount of interest based on your current deposit. Okay. Now, we used the spreadsheets to speed that up, but it took some time, right? If I wanted to get up to 10, 12 years, that was a lot of calculations that the spreadsheet did for us. So what we're going to look at today is that there's actually a formula, so we can take a bit of a shortcut and don't have to do that every single time. Okay, and here it is. This is the compound interest formula. A is equal to P times 1 plus I to the exponent of n. And at the bottom there, you've got some blanks to fill in. So here's what the different pieces mean. Okay, so the P, once again, stands for principal. So that's how much money you're starting with. Okay, the A stands for accumulated amount or final amount, or sometimes you might hear that called future value. So that's how much you will have when the process is over. So this is the final amount with the interest added in. Okay, the I stands for interest rate per compounding period, and we'll explain that in a little bit more detail in a moment. Okay, and finally, N is your total number of compounding periods. So the compounding part is just talking about how often you deposit the interest. So in the example we did yesterday, that was just at the end of each year. So that would be annual compounding. Okay, but for instance, with a bank account, you don't get interest once a year. It usually gets deposited at the end of every month. So it happens multiple times per year. So that's what we're going to start off with, is talking a bit more about how these work. But first, we're just going to review some time things here, because these are some of the terminology you're going to see in these kind of questions when you're asked to calculate compound interest. Right? So again, the compounding period is how often interest is calculated and then added in. So here are sort of your standard possibilities for compounding. Okay, and we're just going to write times per year. And actually, I would encourage maybe to pause the video here and let you try to figure those out for yourself. What do you think those are? And then we'll go over it here. Okay, so we talked about the first one already. Annually is just once per year, so that's one. Semi-annually, so semi, like semicircle, kind of means half. So that is twice per year. Okay, and similarly quarterly, that would be 4 times a year or every 3 months, or maybe once a season. Okay, bi-monthly. Okay, bi, like bicycle, meaning 2. Okay, bi means twice per, sorry, bi means every second month. Okay, so this is going to be 6, right? So every other month you would deposit your interest. Okay, monthly is 12. Okay, semi-monthly, again, the word semi meaning half, so that means every half month you get a deposit, or twice per month. So this is 24 times per year. Okay, bi-weekly, so every 2 weeks. Okay, so maybe we'll just jump down to weekly for a second first. Okay, weekly, and we reviewed this with simple interest, but there are 52 weeks in a year. So for bi-weekly, that's going to be half of that, so 26, because it's every other week. Okay, and finally, and we reviewed this with simple as well, for daily interest, that is 365 times per year. Okay, so now that we have that, we can talk about I and N. Okay, so interest rate per compounding period. So we're going to calculate what they are. So it's the idea that when you're given an interest rate, it tells you how much interest you're going to earn for the whole year. So if you're going to make the deposits at regular intervals, you're only going to get part of that interest. Okay, so 6% compounded semi-annually means it's 6% for the whole year. But because it's semi-annually, we're going to make 2 deposits. So we just divide this by 2, again, because it's semi-annually. And that's going to be 3%. Right? So right, you earn 3% for the first half, 3% for the second half, and that's a total of 6% for the year. Now, if I was going to put this into the formula, we have to make that a decimal. So this is going to be 0.03. Okay, and you might find it faster to actually just do that part first and then divide. Okay, it doesn't really matter. So I think for the rest of the examples, I'll do that. So 5% weekly. So again, 5%, we'll start there. Okay, that's 0.05. And weekly, that is 52 times per year. Okay, so I'm going to grab a calculator here, and I've got 0.05 divided by 52. I need to see that as a decimal. Okay, so 0.009615. 0.000. Okay, what's the rest of it? Now, this is going to look kind of annoying here. But again, like with trigonometry and some of the other stuff we've talked about, it is really important here that you keep a lot of decimal places in your intermediate calculations. Okay, and the reason for that is, especially here, we're talking about money, right? So if you round this too much, like if I just cut it off at the 0.9 or 0.96, okay, you know, for small amounts of money, it probably won't make any difference. But for larger amounts of money, I'm going to be missing out on some dollars and cents if I don't keep the entire thing there. Okay, so last but not least, 1.75 quarterly. Well, so again, we'll change it to decimal first. So it's 0.175. Quarterly is 4 times per year, so we'll divide that by 4. Okay, so 0.004375. Okay, so that's how you get your value for I. It's your interest rate divided by however many times you're compounding per year. Okay, similarly for N, this is the total number of compounding periods. So it's not just how many years it is. So unlike simple interest, it's how many times am I putting the money in. So for example, compounded quarterly, so that's 4 times per year, and I'm doing that for 5 years. So it's just going to be 4 times 5. So it would be 20. My value of N would be 20. Semi-annually for 18 months. Well, semi-annually is twice per year, and this is part of a year. So again, we have to do a little bit of converting here. That's twice per year, but 18 months is 1.5 years. So that's going to be 3. Okay, or another way you can think of that, right, that's every 6 months. So for 18 months, that's going to be 3 of those. Bi-weekly for 2 years. Again, so bi-weekly, that was 26 times per year. And if I do that for 2 years, multiply it by 2, and I get 52. Okay, so that's how you calculate your value for N. It's just what type of compound is it times how many years is your investment going to be. Okay, so now I'll start putting it all together. I'll just do a couple examples of running through the actual calculation. So calculate the amount of investment if $500 is invested at 3% compounded quarterly for 3 years. So like with simple interest, it's handy to list out our variables. Okay, and I think I picked this up from Mr. Sadler, but it's easy to remember them with this little acronym of PAIN. Okay, right? Principal, final amount, interest, and number of compounds. So we'll write those 4 things down, and we'll start filling it in. So P is my principal, so I'm starting with $500. A is my final amount, that's what I'm looking for, so I don't know that yet. Okay, 3% compounded quarterly. So I'm going to start with my decimal. So 3% is 0.03. Okay, but I'm compounding it quarterly. So that's 4 times per year. So I'm going to divide that by 4. 0.03 0075. And for n, that's 3 years, and it's quarterly. So 4 times per year times 3 years is 12. So we're going to have 12 deposits of interest. Okay, so now we'll run through the formula. So A equals P 1 plus I to the power of n. So I have my principal, $500. Okay, 1 plus my I, 0.075. And that's all the power of 12. Okay, so again, now so back to some math work. First step would just be to add these 2 things together, which is pretty nice because it's 1 plus 0 point something. So I'm going to have 1.0075 to the power of 12. Let's try to clean that up a bit. Okay, next step, I would have to do my exponent. So see, this is resembling some of the exponential stuff we did a few days ago. So 1.0075 to the power of 12. Exponent of 12. Okay, so again, there's a lot of numbers there, and we'll try to keep a whole bunch of them for intermediate calculations. So that is 1.0938. Okay, and yeah, I can hear some of you groaning, but yes, you really should leave all those decimal places there until the end. Okay, our last step is to multiply that by 500. So I'll take that number and multiply by 500. Okay, now here's where you can round it off because we're down to just dollars and cents. So it's $546, and rounding it would be 90 cents. So 546.90. Okay, so that means that after 3 years, okay, our investment has grown from $500 to $546.90. Okay, a follow-up question that I could ask is how much of this is actually interest, right? How much interest did you actually earn? So capital I from the other day. Well, this is my new total. So if I now have 546.90, I just take away the initial investment. Okay, so that's how much interest was actually earned in those 3 years, was $46.90. Okay, this is how much is in the bank, and that's how much of it is interest. Okay, speaking of which, example 4 is asking us just that. How much interest is earned if $2,000 is invested at 2.25% compounded monthly for 2.5 years? So we'll set it up the same way. Right? I have my principal, I have my final amount, I have my interest rate, and I have my number of compounds. So I'm starting with $2,000. Okay. Don't know what my final amount is yet. Okay, I have 0.0225. That's my interest as a decimal. We're compounding monthly, so I'm going to divide it by 12. 0.001875. Okay, and for n, it's monthly, so it's 12 times 2.5 years, which I believe works out to 30. Okay, and now it's just going to be the same process as before. So we have my final amount is equal to the principal, 1 plus the interest rate to the power of n. So I have 2,000, 1 plus 0.001875 to the power of 30. Okay, my first step would just be to add those together. 1.001875 to the 30. Okay, now again we do our exponent next. So let's see here. Okay, 1.057806,402. Okay, and finally just take that number and multiply it by 2,000. And I get 2,115.61 when I round it off. Okay. So that's the final amount of my investment. It was asking me how much interest I earned. So for my interest, I'll just take my final total there, 2115.61, and subtract the original $2,000. So that means I have $115.61. And that's how much interest we've earned in those 2.5 years. Okay. So yes, like the simple interest, okay, it's formula work. Okay, it's just setting this up, plugging it in, and running it through. Okay, so again, you need to spend some time practicing to make sure you've got that pattern down. So for practice, we're going to go to our textbooks. Okay, and starting on page 432, those are the 6 questions I would like you to have a look at. Okay, in tomorrow's lesson, okay, hopefully I'll be back for that. We're going to start talking about how to solve for the other things in that equation, right? How do you solve for p? How do you solve for I? How do you solve for n? We'll get into some of that stuff there. All right, so have a wonderful rest of the day, and I will hopefully see you tomorrow.